Alright, this is the Transformers More Than Meets the Y task covering transformations on a quadratic function. The task looks like this and can be found in your workbook or your Canvas account. If you missed class today, you should pause this video and go work through the task yourself before coming back to watch this video. If you were in class today but didn't quite understand what the main math ideas were, then you are in the right place. Alright, number 1 reminds us of our matching problem yesterday. So if we draw this situation, which is very similar to what we had yesterday in number 1, we have a square with side lengths of x plus 4 because of this increased by 4 in the word problem. Thus we have side lengths of equal length because it's a square. So we have an area of x plus 4 squared. Then we are going to add 8 to the area. So this area, we're going to add 8 to it. And we are going to multiply the area by 3. And this is because it tells us that the area is multiplied by 3, and then 8 square units are added to the area. So the equation we have is a of x equals 3 times x plus 4 squared plus 8. This is similar to the number 1 that you have, but different numbers. You may go do that whenever you're ready. Then in number 2, we have a graph that shifts right 3. 1, 2, 3. And up 4. 1, 2, 3, 4. And it has a growth factor of over 1 up 2. So, as we saw yesterday, if we want to shift right, we need to add or subtract something to the x before it is squared. So we're going to have parentheses and have x. We discovered yesterday that the sign is opposite our expectation, so this is going to be x minus 3 squared. Then the up 4 is added after the x has been squared, so that is on the outside here. And the growth factor of over 1 up 2 means that we multiplied the area by 2. So in our case, we're going to have 2 times x minus 3 squared plus 4. Your number 2 looks just like this, but with different numbers. This one looks like your number 3. So we're looking at a table instead of a graph, and it's similar to your homework from last night. We know the quadratic functions are symmetrical, so if we look for the point around which the table is symmetrical, we will find the vertex. You'll see that we have equal numbers here, equal numbers here, and so our point around, our vertex point around which the table is symmetrical is 2, 3. This shows us that our right movement is 2 and our up movement is 3. So we're going to put x minus 2 in the parentheses, square it, and add 3. Since the vertex is right 2 and up 3 from 0, 0. Plotting the table shows that it's downward facing. So if we were to put this in Desmos or plot this on a graph, we have 2, 3, and 1, 2, and 3, 2, 4, -1, and 0, -1. So we can see that this graph is downward facing. And so we know that this needs to be negative. You should be capable of doing numbers 1 through 4 now by yourself. So we're going to move on to look at number 5, where it asks us to graph the equation without technology. We know that adding or subtracting to x squared moves the graph up or down, so the vertex moves down 5 from 0, 0. So we'll plot the point 0, -5, because we're moving down 5. Then the -1 in the A means that we reflect the parabola over the x-axis so that it's concave down. So instead of going over 1, up 1, we're going to go over 1, down 1, and plot our new point. Then we're going to go over 1, down 3, and plot our new point. And so our parabola looks like this. You can go plug this equation into Desmos and confirm that, but you want to make sure that you're graphing without technology first. I'm going to go ahead and skip to number 7 because number 6 is similar to number 7 and number 5 combined. So in number 7, we see that they have something in all the places. So if you remember, we have y equals a times x minus h squared plus k. And so we have an a of 2, that's our growth factor. We have an h of 4, that's our right-left movement. And we have a k of 6, that's our up-down movement. So we know that adding or subtracting to x, that h is going to make us move left or right, and and subtracting it, or that it's going to be opposite of what we want. So subtracting it is going to be moving it right 4. So we're going to move right 4 from 0, 0. And then on the outside, it goes with the same sign that we would expect. So we're going to be moving up 6 from 0, 0. So we have a vertex of 4, 6. And then this 2 is our growth factor, so that tells us that we're going to go over 1 and up 2 from that vertex. And we can sketch our parabola from there. Again, you can go type this into Desmos or into your technology now that you have plotted it, and we will see that that is indeed the case. So as we saw here, our vertex comes from our h and our k. So the vertex is hk, just as you saw up there, the 4 and the 6, hk. The h being the opposite of the sign inside the parenthesis. The equation of the line of symmetry, we know, goes through the vertex and is a vertical line, and so it has to be x equals whatever number is in that h location. We've talked about how the parabola opens up or down based on the a being negative or positive. So this is when a is positive, it opens up, and when a is negative, it opens down. Finally, when we identify the dilation or the stretch factor, the growth factor, we're looking at our a value. And so this is our a. And when a is bigger than 1, when the absolute value of a is bigger than 1, then it stretches. And when the absolute value of a is smaller than 1, it compresses, becoming wider instead of skinnier. The answer to number 9 is no, it does not matter. And this is because at least, or only one of them is a non-rigid transformation. So you can do any of them in any order that you'd like. For more support, go visit Canvas to find the Ready, Set, Go videos and the county website to find unit overview sheets with links to practice problems and other video help.